Okay, we're in section 13 now, and again, we're going to just review this material about what you need to do. You need to read the contents, you need to understand the examples, and then get busy with the exercises. All right, so it's a long journey, though. We're at 13, and we're going to get to 139 eventually. But again, this is all about doing this material, which means contents, examples, and exercises. For those people who need to reach out to me, my name is Ron Bannon. My email address is Bannon, B as in boy, A, N-N-O-N .us. All right, let's scroll through the material. What's this about? It's about factoring, more factoring. They have patterns, and they're suggesting that you follow these patterns, all right? And we'll go through that. So certainly they give examples. I'm going to say that's all we're going to be doing. It's a short section. And, certainly when I say it's a short section, there's really not much to be said about it, other than the fact there's a pattern to it. Now, my belief about patterns is they really kind of like, you look at something and say, well, it's got to be a pattern to it. Let's just take a look at it. And I'm going to look at it. It doesn't look like exactly what I want it to look like. So, this happens to a lot of students when they're looking at work and how can I get that to look like what they want it to look like? Well, let me just go back in the notes and point out to you, it can't hurt to go back and look. And I want to point out, looking at it, there's something about these problems over here that you study them and you start to say, maybe I could get it to be a perfect square, all right? Maybe. What I mean by that, maybe I get this thing to look like this over here. Or maybe something entirely different. But I don't see it yet. And I don't see this either. And I don't see this. I'm expecting to see those things. So let me take a look at that. I'm going to write down A4 plus 2A squared B squared plus B4 minus A squared B squared. Now, I got to be honest, this is really the same thing. But why did I do that? I did that because this first guy now is a perfect square. And what is it? A squared plus B squared squared minus A B squared. So I see my pattern now. What do I see? A squared plus B squared minus AB. We'll look at the key later. A squared plus B squared plus AB. There's nothing wrong with this answer, by the way. Right? Where's that answer? That answer is actually right here. Now, I realize some say, why'd you reorder it? Well, I think in some respects, to reorder it's not a bad idea. So I'll point out, in terms of A's, this would be A squared minus AB. What I mean by that, descending powers of A, and then B squared. That's a square. Let me get my eraser out. That doesn't look right. And again, some people's penmanship is better than others. My penmanship's pretty bad. And this would be A squared plus AB. I did it again. Okay? All right. A little bit of a take-home message. If you give this to a student nowadays, they would look at it and they couldn't do what we just did. And the reason for that, even though you tell them there's a pattern there, they may not be willing to look for it. And that's what we're trying to get across to you. You really have to look for embedded patterns in a problem, all right? So let's look at this one over here, the next one. And I'm looking at, like if I were in, a basic algebra class, I'd say, okay, let me give it a try. And I got to be honest with you, no matter what, maybe not. Maybe I can do it. Let's take a look at that. I shouldn't say we can't do it. I'm going to say 9x squared x squared, and then I'm going to say 4 and 1. Let me see if that works. What do you get? Yeah, you get 9x4. That works pretty good. Then you get minus 36 minus 1, which is minus 37. Yes, worked beautifully. And this is difference of perfect squares. So what do you get over here? 3x minus 1, 3x plus 1, x minus 2, x plus 2. Let me circle that over here for you. I want to go to the answer key. I want to point out they did it a little bit differently initially. They did it the way that Wells would introduce it over here, but they still got to the same answer, right? I also did it, a slightly different way. Again, the way Wells would have done it over here. But when I first looked at it, I said, it really doesn't look that bad. And I just did it by just factoring it. I assumed it was doable, right? Now, someone says, could you have done that one over here? No, I couldn't have done that way, right? No, nothing I could have done could have come up like that. When I say I didn't see what I could do to get that, I just didn't see it, right? I didn't see it. All right, so let's keep going. Oh, there's only 2 examples. That's good. What do you get now? Exercises, things for you to try. And by what I mean by that, try. And what do you mean trial and error? What Wells is doing by looking for simple patterns and moving your way through it. Yeah, I do give you answers here, and I hope that's not distracting to you. Certainly, if I were doing the question, I would do the question on a piece of paper without looking at the answer. Then after I finished it, that's when I'd look at the answer. I would do number 2 on a piece of paper. I would not look at the answer. Then I would look at the answer, so forth and so on, all right? You should see it as an advantage. Have an answer nearby, though. It's like having a tutor right next to you telling you this is what it should look like, all right? They're right next to you at all times, all right? Again, the format should be really, really familiar to you now. Make sure you do those exercises. Make sure you read the content. Make sure you understand the examples. And if you want to and you have access to this website, maybe thinking about doing the download the software or just using the interactive web-based thing to do the code that's over here. Thank you very much.